In this case, we are responding to a POST request and expect application XML input which would be deserialized into the customer parameter. The customer parameter is an entity parameter and is mapped directly from the message body of the incoming request. We also override the default application XML output specified by the customer resource class and specify text HTML instead. After adding those three methods, your wizard should now look like this. You will see a class with stubbed out resource methods as shown below. This is the code. We must now provide implementations for the methods created by the above wizard. In a real application, at this point we would probably wire in a database using JPA or Hibernate to help manage our customer list, but a simple in-memory map is sufficient for this tutorial. Our implementation is simple. When a customer is received by our service, we give the entity a counter-based ID and add to it our map. Retrieving a customer from this map by ID and providing a list of customers is straightforward, as you can see below. You may copy this implementation into your class. Observe that the class and method signatures have not changed. All we are doing is fleshing out the generated stubs with an implementation of our service. We also add a single customer to the list of demonstration purposes. You can invoke the JAX-RS methods wizard directly for any class in the REST web service project by using the add_REST method. Context menu action. Right-click in the Java editor to bring up the context menu and select the add_REST method from the My Eclipse submenu. You can see that in this picture. Deploying and testing the web service. Deploying and running the REST demo project. The fastest way to deploy our web service is to deploy our web project using the run as or debug as action of My Eclipse server application. We can do that by right-clicking on our project, going down to debug as or run as and selecting My Eclipse server application. This picture shows that. If you have multiple server connectors configured, My Eclipse will ask you which one of you want to use. For the purpose of this tutorial, select My Eclipse Tomcat. If you don't have any connectors configured, My Eclipse Tomcat will be used automatically for you to deploy your project to and then run. Now My Eclipse will perform the following steps for you automatically. First one is package our web project and deploy it in exploded format to the application server. Second, start the application server for us. Loading our web project, the My Eclipse web browser will pop up and show you the default index.jsp page of our web app. We don't actually need this because we are not testing a web page, so you can close this view. Testing the web service with the REST Web Services Explorer, PRO only. The easiest way to test our web service is to use the REST Web Services Explorer. Since the Explorer is available only to My Eclipse Professional subscribers, if you are My Eclipse Standard subscriber. You may also open the REST Web Services Explorer using the drop down from the main Eclipse toolbar. In this case, You need to manually enter the path of a WADL file in the address bar before proceeding. Expand the customer's node and select ID. In the ID field on the right, enter 0 and click Test. In the Raw View tab, observe the lone customer we have in our map being returned in XML. As shown in this picture, let's add a customer to our list. Expand, select Add under the customer node. In the content area on the right, paste the following and click Test. The response should now say customer bill Adama added with the ID 1. Number 4. Select the customers node and click Test. The two customers in our list are returned by the service in XML. Testing the web service using a standard browser. First, open http localhost 8080 REST demo services customer node in your browser to see the first customer in XML. Second, to add a customer to our list, we need to send customer data to the service via an HTTP POST request. You could use a Firefox extension like Poster to make the request as shown below. Open http localhost 8080 REST demo services customers in your browser to get a list of all customers in XML. When to use REST? Architects and developers need to decide when this particular style is an appropriate choice for their applications. A RESTful design may be appropriate when the web services are completely stateless. A good test is to consider whether the interaction can survive a restart of the server. A caching infrastructure can be leveraged for performance. If the data that the web services returns is not dynamically generated and can be cached, then the caching infrastructure that the web servers and other intermediaries inherently provide can be leveraged to improve performance. However, the developer must take care because such caches are limited to HTTP GET method for most servers. The service producer and service consumer have a mutual understanding of the context and the content being passed along. Because there is no formal way to describe the web services interface, both parties must agree out of band on the schemas that describes the data being exchanged and on ways to process it meaningfully. In the real world, most commercial applications that expose the services as RESTful implementations also distribute so-called value-added toolkits that describe the interfaces to developers in popular programming languages. The service producer and service consumer have a mutual understanding of the context and content being passed along, because there is no formal way to describe the web services interface. Both parties must agree out the band on the schemas that describes the data being exchanged on the ways to process